I would like to explain the solution for the section of linear equations using Jacobi method by hand. Firstly, we set the initial iterative of x1, x2, and x3, x0. From the section of linear equations, we form the equations of x1, x2, and x3 from the first, second, and third linear equations respectively as shown in the diagram, in order to find the value of the iteratives. Then, we substitute the value of the initial iterative of x, which the value is 0, into the x1, x2, and x3 respectively to find the first iteratives. After that, we found that the x1 is equal to negative 0.200000, x2 is equal to 0.222222, and my x3 is equal to negative 0.428571. After we find the first iteratives, then we find the value of the second iteratives by substituting the first iteratives to the equation of x1, x2, and x3 just now. Then, we repeat the steps to find the third, fourth, and other iteratives until we get the system converges. This table shows all the iteratives that we found until the system converges at 12 iteration, where the x1 is equal to 0.186120, x2 is equal to 0.331230, and x3 is equal to the negative 0.422713.
So, I will discuss the coding of Jacobi method. For input is our question, which is matrix A, matrix B, and also initial condition x0. D1 is to find the diagonal of matrix A, then continue by D2, which will form the diagonal matrix. NL and NU are used to get the strictly lower triangular and upper triangular matrix. For input A, L and U are to negative the value of NL and NU to map our formula of Jacobi method. ID is the inverse of D2, which will be used in the command without linear solve. ABS absolute value is 1 times 10 to the power of negative 7, and it is the condition used in the if statement afterward. The formula of Jacobi method is shown in the pink region. Our do loop coding with linear solve. Take notes with line 2, the number 7 after comma means we will print out output with 7 decimal places. The following line is the if statement, which is the condition used to break our loop. The if statement means that our output will break when the norm of xn minus 1 is less than our absolute value. So, our output is shown below and our iteration stops at the 13th iteration. The next tree coding is the alternative method of the coding discussed just now, and they are do loop without linear solve, for loop with linear solve, for loop without linear solve. They will also show that all the iteration will stop at 13 iteration.
Hi everyone, my name is Nofaisha binti Muhammad Latif and my matrix number is D202010956665. In this video, I will explain step by step by using Gauss-Seidel method. Okay, the given question is 5x1 minus 2x2 plus 3x3 equal to negative 1. We call it as first equation. Next, negative 3x1 plus 6x plus 9x2 plus x3 equal to 2. We call it as second equations. Next, 2x1 minus x2 minus 7x3 equal to 3. We call it as third equation. The x0 is 0, 0, 0, which means that x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0 for the first iteration. The first step, by using first equation, we need to move all the numbers and the variables that are on the left side to the right side except for the x1. We will get x1 is equal to -1 plus 2x2 minus 3x3 over 5. We call it as equation x1. Next, by using the second equation, we move everything from the left side to the right side except x2. We will get x2 is equal to 2 plus 3x1 minus x3 over 6. We call it as equation x2. By using the third equation, we will move all the variables and the numbers from the left side to the right side. We will get x3 is equal to 2x1 minus x2 minus 3 over 7, and we call it as equation x3. Now we need to find the first iterative for Gauss-Seidel method by using equation 1, equation x1, equation x2, and equation x3. So the first iterations is based on our equations x0, we have x1, x2, and x3 is equal to 0, and then we will substitute the values of x1, x2, and x3 into the equation x1. Then we get x1 is equal to -0.2. Next, we need to find the x2 for the first iterative by using the equation x2. We substitute x1 from the first iterative, which is x1 is equal to -0.2 and x3 is equal to 0. Then we will get x2 is equal to 0.155556. And then next we need to find this x3 for the first iterative by using the equation x3. We substitute x1 from the first iterative is -0.2 and the x2 is 0.155556, and then we will get x3 is equal to -0.507937. So we can write down our first iterative is x1 is equal to first iterative is equal to -0.200 and 0.155556, -0.507937. We will repeat this step to find the next iterative until it converges. After converge, we will stop looking for the next iterative. So for this equation, we will find that it will converge on the seventh iterative, which is the system converge at 7 iterations where x is equal to 0.186120, 0.331230, and -0.422713.
So, I will discuss about the coding of the Gauss-Seidel method. For input 1 is our question, which is matrix A, matrix B, and also our initial condition x0. D1 is to find the diagonal of the matrix A, then followed by D2, which will form the diagonal matrix. NL and NU are used to get a strictly lower triangular matrix and strictly upper triangular matrix. For input A, L and U are to negative the value of NL and NU to map our formula of Gauss-Seidel. The ID is the inverse of D2 minus L, which we'll use in the common without linear sort. we let A be as absolute value to 1 times 10 to the power of -7, and it is the condition used in the if statement afterward. The formula of the Gauss-Seidel is shown in the pink region. Here is our do loop coding with linear solve. Take note with line 2, the number 7 after the comma means we will print out our output with 7 decimal places. The following line is the if statement, which is the condition used to break our do loop. The if statement means that our output will break when the norm of xn minus xn minus 1 is less than our absolute value. So our output is shown below and our iteration stops at 8 iteration. The next pre-coding is the alternative method of the coding discussed just now, and they are do loop with linear solve, for loop with linear solve, and lastly, for loop without linear solve. They will also show that all the iterations will stop at 8 iterations.
Now I will explain the comparison between Jacobi method and Gauss-Seidel method. First comparison is the iterative formula. Second comparison is the convergence. For Jacobi method and for Gauss-Seidel method, converges for diagonally dominant or symmetry positive defined matrices. Third comparison is the initialization. Jacobi method and Gauss-Seidel method require an initial guess for the solution vector. Fourth comparison is the speed. For Jacobi method, slower than Gauss-Seidel method due to independent updates of each component of the solutions vector. For Gauss-Seidel, faster than Jacobi method due to the use of updated component in the same iteration. Next comparison is the memory. For Jacobi method, uses more memory than Gauss-Seidel method as it stores two solutions vector for each iteration. For Gauss-Seidel method, uses less memory than Jacobi method as it updated only one component of the solutions vector at a time. Next comparison is the parallelization. For Jacobi method can be parallelized easily as updates of each component of the solutions vector are independent. For Gauss-Seidel method can be parallelized but require synchronizations between neighboring components. The eighth comparison is the variant. For Jacobi method, successive over-realizations SOR method is a variant that can be improved convergence speed. For the Gauss-Seidel method, red-black Gauss-Seidel method is a variant that can be improved convergence speed and can be parallelized more efficiently than the regular Gauss-Seidel method.